Hello, how are you? I hope you will be fine today. I am here to present you the third video of Doosan excavator DX140 that is related to the troubleshooting and repairing guide. This is very important video, so I will try to cover all the topic in my this part 3 video. So be attentive and listen the points which I will discuss in this video. So make sure that you get all the information at the end of this video. So let's start our topic. This is Doosan excavator DX140 Before, we have covered 4 topics in our 2 videos, and there was one additional video with machine components detail. So that was very important, as you should have the knowledge of component before going to part 3, before starting part 3 video. So in my previous videos I have covered introduction, machine safety, machine specification, general maintenance, and there was one separate video that was related to the components of the machine. So you understand and familiar yourself with the component of the machine. So today our topics are troubleshooting and repairing of this machine. In this first slide you can see the instrument panel in front of you. You will find this instrument panel in the operator cabin of the machines. So this is the instrument panel. There is numbering also for this display panel, and each number detail is given in the below table. So if I start from this one, this is the fuel gauge, second engine coolant temperature gauge, third is hydraulic oil temperature gauge. At the bottom you can see the button. There are different function of these buttons. You can see here the detail. So on 4th you will see the RPM. On 4, this is the multi-function gauge and graphic information area. So here you can see the information. Later we will discuss this graphic information in this video. We will also discuss the graphic information. 5 is the digital clock, 6 hour meter, and this 7 is the charge warning light, 8 engine oil pressure warning light, 9 coolant temperature warning light, 10 engine check light, and so on. You can see the detail of other things. Number 13, this is the power mode selector switch. Number 14, this is work mode selector switch. 2 switches are given. If you see at 13 number, there is power written on this button. This is power mode, and the below one is the work mode selector switch. 15 is auto idle. If you want to keep your engine at auto idle when machine is running without any load, machine is standing idle without any load, so automatically this will switch the engine to idle mode from high RPM. Sometimes we forget to bring this RPM lever or RPM switch to down RPM position, so it will automatically switch this RPM to the idle position. 19, this is display switch, and 20 is the enter switch. So now we will discuss the operation of instrument panel. We will discuss operation of this instrument panel. So this is coolant temperature. You will find like this coolant temperature gauge. So this is has communication with the engine control unit. ECU stand for engine control unit, and this has linked up with this ECU through this CAN communication. CAN stand for controller area network. So this is robust type bus, and what is the function of this CAN? This allows the devices and microcontroller to communicate with ECU without any host computer. So there is separate detail for this CAN. If you are eager to study this or want to learn about CAN, this is separate topic. You can find the videos relating to CAN. But just this is information for you. You keep your knowledge to this point, because this is separate job for the CAN. This is used for troubleshooting of the machine through laptops, computer, and soft tools. That is very that is different topic. Second one, fuel level gauge. Here you can see the fuel level. This 1/10 red zone blinking. So here when your light blink, the resistance would be above 5,000 ohms. So when your fuel tank is full, this gauge needle will move to the F position, and here you will get the resistance 520 ohms. So this resistance, according to the change in resistance, current, this more volt passes, and this needles moves accordingly. So this needles depends on the given current. So if resistance is lower, this will move accordingly. So what thing that controlling this resistance? There is float switch inside the fuel tank through which this resistance is controllable. So according to the level of the fuel, this resistance becomes high, low. So as per resistance value, this needle deflects. Here you can see this hydraulic oil temperature gauge. This shows the hydraulic oil temperature. You can see also in the gauge there is hydraulic cylinder sign with this oil sign. So there I will upload a separate video relating to the hydraulic symbols and electrical symbols. So in this way you will be able to get the knowledge how to read this schematic. These schematics, hydraulic or electric. So this will help you for understanding these schematics in more efficient way. So here you can see this 40 centigrade, 50 centigrade, 60, 94, 96. So here you can see the needle will move accordingly, and this resistance is changing with respect to the temperature increase. If temperature is increasing, resistance graph will move down. You can see at 40 centigrade there is a lower temperature. So here you can see 1397 ohm, and at 96 this is the highest temperature. Here you can see the black area at 96 centigrade. This is very high temperature, and this will prevent the engine from starting. Maybe this switch off your engine, shut down your engine. So this is flow adjusting of hydraulic. This LPM stands for liter per minute. So here you can see the value of the current. What should be the value of current at wires? during this pressure. So as current increases, the flow value become low, and as current decreases the flow value gets higher. So there are solenoid and switches on the hydraulic pump, so this current is controlling the proportional solenoid valves, and this current opens the pilot pressure for moving this switch plate inside the hydraulic pump for controlling the flow of the hydraulic pump. So as per change in the values, what flow you select from this adjusting area. Here I can see if I select this 24 liter per minute, then there will be 605 milliampere current at the solenoid coil. So this current, if you move it to 38 liter, so there will be lower current, 538 milliampere. This depends upon your selection. Let's suppose if I select this 149 liter per minute, there would be 341 milliampere current at the solenoid. So as current decreases, the flow rate increase. This is all arrangement made by this hydraulic control system, and installation of solenoid. So now we will discuss the warning and indicator lights of this instrument panel. See, this is the battery sign. So in case no charge or voltage are below than 12 plus minus 1 volt or overcharge, so this signs will illuminate in the display. This tells the operator there is problem with the battery. It could have low charging or overcharging. Second is, you can see this sign with the arrow mark directing inside and toward the symbol. This is engine oil pressure indicator. So when you start the engine, after 8 seconds, this light should turn to the off position. Otherwise, a warning buzzer will sound, and this will indicate that oil pressure is in low range, and this is not good for operating an engine in safe condition. This is the engine. Third one is engine check light in case there is failure in the engine system. This light will indicate on the display. This is the coolant temperature. When there is high coolant temperature, this sign will illuminate on the display, and this will warn the operator that high coolant temperature. There is also sensor, and values change according to the change in resistance. This is the preheating sign. So preheating period depends upon the coolant temperature. So if your coolant temperature is above 10 centigrades, there would be no preheating when you turn your ignition switch to the on position. But if the temperature is below 10 centigrade, then you can see also here is 10-second preheating for 5 centigrade and 20-second preheating for 0 centigrade. This is the temperature, ambient temperature. This is the park brake sign, and this lights illuminates in the display when you put this park brake switch or lever in parking position. And in case your parking pressure decreases 377 psi, these lights will also illuminate in the display panel. This is the hydraulic oil temperature symbol. You can see thermometer beside the symbol, so whenever you see the thermometer with any sign, so please remember one thing, this is related to the temperature. So what signs? This is the hydraulic cylinder. Inside you can see the drop, so this shows the hydraulic, and this tells the operator hydraulic temperature is about 90 centigrade or above 90 centigrade. So this warning lights comes in the display when your temperature is 90 centigrade or above 90 centigrade. This is fuel sign, almost fuel exhausted. This sign will display in the screen, and you can see this sign when air cleaner is clogged. This sign will display in the instrument panel. This one the operator that now you have to clean the brake cleaner. This will restrict the passage of air, so there is sensor or switch installed on this pre-air cleaner. This is the return filter pressure warning. When return filter pressure is about 21 psi, this warning will come in the display. Last one, the pilot filter pressure. When pilot filter pressure is above 14 psi. So for return filter pressure, what is the difference between both signs? How you can make a difference between two signs? So there is R and P denoted with these two signs. So R mean return filter. This is the return filter pressure warning, and second one is P, and this for pilot filter pressure warning. Graphic information area display. Now we will discuss the graphic information area display. Here you can see the instrument panel. Before just I told you about this display in my start of this video about the buttons and display area. So here you can see, now we will discuss about this graphic information of this panel. This is not only display. There are certain functions in this screen through which we can approach the faults and other troubleshooting area of this machine. So now we will discuss this graphic information. Here you can see this one is up arrow button, 2 is down arrow button, on 3 this is the enter button, and 4 is the escape button. So on 5th, this is the letter information display department, where you can see the warnings and other displays. So main menu of this display, when you press this ESC button for more than 3 seconds, the main menu screen will display. Main menu screen you can see on the right side, there is language, set clock, filter oil information, adjust display and set password. Let's suppose I want to enter this language section. So what I will do, put the cursor through this up and down arrow button on language, and then press the enter. So default language is Korean, because this is Korean made Doosan excavator, so that's why default language is Korean. You can choose according to your territory or country. Let's suppose you can choose English, German, Chinese, other languages also. Let's see, sorry, there are two languages only, Korean and English. So you can choose English because English is universal language and everyone can understand in English, so you will choose the English. So choose up and down arrow buttons. Here you can see, select the language display and press the enter button, and select language is indicated in the right bottom of the screen. So once you will bring the cursor on this language, you just press the enter button. This will display the two languages, Korean, English. You can move cursor up and down by the up and down arrows button. So at this point, when you select this one language, if you will press the enter button or escape button for more than 1 second, this will display the main menus with the change language. Without pressing a bit more than 20 seconds, the default view appears. So here you can see the clock, how you can adjust the clock. Here you will find this filter oil information. This mode display total operating hour of filter and oil. After changing the filter and oil, reset the operating hour and then operating hours until the next interval can be easily checked. Okay, from here you can set your maintenance schedules. So this will display the total running hour of the machines from last replacement of filters and oil. So it will indicate the operators that how many hours the machine has been run from last oil change. From here you can adjust display. This is clock setting, already we have discussed. Before we have discussed this main menu, now we will discuss the special menu. In this menu, many types of operating condition and function can be assessed and displayed, including the EPOS controller. This menu is mainly used for machine testing and failure diagnostics. So this special menu is mainly used for machine testing and failure diagnostics. So keep remember these points. Before we have discussed the main menu. What main menu we can adjust the clock, adjust the display, we can adjust the operating hour from service point of view, and we can choose the language also. But this special menu is mostly related to the testing and failure diagnostic. The special menu offers 3 sub menus: machine status, failure information, information and machine operations. So entering, accessing and exiting, escaping menus. Entering, accessing menus when normal mode screen is displayed. If the enter button and escape button are pressed simultaneously for more than 3 seconds, if you press this enter and escape button simultaneously together for more than 3 seconds, normal mode screen will be changed to the special menu screen. So how you can assess? You will press the enter and escape button simultaneously for more than 3 seconds. So normal mode screen can display many kinds of display mode by selecting, for example, engine speed, battery volt, front pump pressure, rear pump pressure, and so on by selecting. Special menu. Special menu. Special menu already I told you consists of 3 sections: machine information, failure information, and operating hour. Exiting and escaping menu is if escape buttons is pressed for more than 1 second, the special menu screen will be returned to the normal mode screen. If special menu is on without any activity for more than 20 seconds, let's suppose you open this special menu and this is on for more than 20 seconds without any activity, so this screen will turn to the normal mode again. If you start to switch to the off position and then turn it back to the on, the normal mode screen display again. You have to choose again this special menu. Special menu selection. Here you can see where various sub menus can be selected by pressing up and down button. Move the cursor to desired menu and selected menu will be inverse displayed. So when you see the special menu screen in front of you, by pressing this enter and escape button for more than 3 seconds, the special menu screen will display with the sub menus. So you can choose the desired menu by moving this cursor up and down. When the selected menu is displayed, press the enter button for menu selection. Let's suppose I want to choose this machine information sub menu. So I will bring the cursor on machine information sub menus and I will press the enters. After pressing the enters, you can see in the bottom screen there are 3 categories displayed against this machine information: analog input state, digital input state, and digital output states. So entering sub menus, when cursor is located on machine information of special menu screen, press enter as I told you already and machine information will be displayed. If let's suppose you want to exit these sub menus, if you press this escape button for more than 1 second, display will be turned to the previous screen of special menus. So here you can see the analog input state. Cooling fan, flow control, accelerator pedal, TPS. Keep remember this special menus jobs can do the authorized and specialist who have knowledge and familiar with the machine operations, machine's components, how this machine works. This special menu is designed for those experts who are experts. So here you can see boom pressures, pilot air pump pressure, boost pressure, intake manifold, engine oil pressure, engine oil temperature. This is the digital input state, alternator, travel mode, selector switch, high speed switch, pressure switches, engine oil pressure switch, return filter clock, decoupler, digital output state, third one. So here you can see this digital output state, relief pressure, up, high speed solenoid valve, swing priority solenoid valve, reverse fan solenoid valve, not applicable, not installed with this machine. So after heat relay, this is also not installed in this machine. Start relay, so what I told about special menu selection, this special menu is designed for troubleshooting and testing purpose only. Only authorized and expert can approach this special menu screen. He can check these are failure information. Second one, here you can see when cursor is located on failure information special menu screen, press the enter button. This will bring you in failure information. If you want to go back on the previous screen, then press this escape button for more than 1 second. This will bring you back on the previous screen. Failure record deletion. This mode is used to delete the memorized record of past failure. If this mode is selected, our record will be deleted. So in failure mode information, you can delete the all previous record. Let's suppose there was warning of return filter or any failure, and then you replace the parts and you get it repaired. You can delete this past failure data from this screen. So here all fail log will be deleted. Here you can see this failure already have been deleted from the screen. So if you see any failure detail, you just put the cursor on that failure detail and press enter button. So this will result in deletion of this failure detail. At this time, deletion signal will be displayed and the screen will move to the previous menu after deletion. So once all the data deleted, the screen will move to the previous menu. This screen will be displayed during 3 seconds. So now we will discuss the failure information code at machine site. Keep remember this is these codes are related to the machine side. Here you can see if you find these codes, failure codes, each code have description and starting from the V. So let's suppose I start from V201 gauge panel communication error. You check the related function of gauge panel, troubleshoot what is the problem, why this gauge panel is not getting signal for communications. V202 ECU communication error. So V210, this is pump proportional valve error, flow control proportional valve, and vice versa. You can see all the detail from this chart. So now fill in information code at engine side. These are the engine side code. You can see 011 coolant temperature sensor code. Now I read this E032 fuel pressure monitoring, E042 engine speed crankshaft. This failure E042 is related to the engine speed crankshaft failure. So check the sensor of crankshaft speed sensor and also this camshaft. Let's suppose if I see the C047 when the pressure sensor of common rail or high pressure pump has a defect. So if there is failure with this pressure sensor of high pressure pump or common rail, this code will display. E048, this is power supply issue, and E051 main relay ECU problem. There are a lot of codes for this engine. You can check code detail here in the chart. There are also this E097 to E103. These codes are related to the cylinders because this machine has a 6-cylinder engine, so 6 injectors are installed with this engine. At the top you can see this E058 to E064 because this is electronic machine and electronic injector are installed with this machine. This code will display the injector, which cylinder injector is malfunctioning or not getting power. You can see the detail here from this table. So failure mode identifiers, there are also FMIs. This is the FMI details. You can see FMI 0 mean above normal range, data valid but above normal operating range. This will display with each SPN diagnostic code. So this will tell you about the current voltage of that system. Let's suppose if I talk about this FM5, this is current below normal or open circuit. So you will find this failure mode identifier code with each code. This will tell you about the condition. Electronic control system of hydraulic system, EPAS system. Here you can see the EPAS. EPAS is basically machine ECM, electronic control module EPAS. This Doosan has given this name EPAS controller, so this is controlling the all functions of the machine side. And this EG is the engine control module on number 3. And number 2 you can see this EPAS controller. 24, this is the accelerator pedal. At 17 engine control dial. 21, this is the sensor. At 19 position work mode travel switch. These all switches are connected to this EPAS controller. So when we press or move any toggle switch, this sends the input data and this EPAS then pass this information to the related solenoid sensor or switch as output. So you can see here the detail. This also display is connected with this engine control module. So all information are displayed on this instrument panel relating to the failure and other machine parameters. E-pass and engine control unit are connected with each other. This pass the information. Here you can see this engine control system, and number 2 position E-pass controller, and number 3 this is engine controller. At 17 this is engine control dial, and 24 the accelerator pedal. When the engine control dial is moved to the output voltage change according to the dial position, the E-pass controller converts this output voltage of dial to the digital signal and send it to the engine controller by Guideline. So already we have told you about this CAN controller area network through this line. Already I told this send the information without any host computer to the ECU. So what is said, when the engine control dial is moved, when we move the engine control dial, this RPM dial, when we move, output voltage change according to the dial position. So according to our selection, this output voltage changes. And what E-pass does, this controller converts output voltage of dial to digital signals and sends it to the engine controller by Guideline. According to the dial command, the quantity of fuel injection is registered. So according to our accelerator positions, this quantity of fuel is adjusted. So both have interlinked with each other. So electrical system, now we will discuss the electrical system of this machine. The electrical system for this equipment is 24 volt DC machines. 2 batteries are installed with 12 volt. So the rated voltage for all electrical component is 24 volt, with the exception of the stereo and air condition control actuator. So some accessories that needs 12 volts. There is also converter that converts the 24 volt into 12 volt for some accessory. So the system contains 2 12 volt batteries connected in series and a 3-phase AC generator with a rectifier. So already I have told you 2 12 volt batteries are installed in this machine. The electrical wiring used in the system is easily identifiable by the insulator color. So now I will tell you about the wirings colors, how you can identify the wires colors, and here you can see if W symbol is written on the wire, this means this white color wires, G green, or orange, B black, and likewise you can see below all the color in front of symbols. So let's suppose if I see this Y symbol, this show this yellow color. So some wires like this are W. What is mean? Red wire with white strip. So the wire color will be red, but there would be white strip inside the wire. Red is the base color and W is the strip color. So first symbol will display the base color and the second one will display the strip color. So these symbol will help you when you are reading the schematics drawings. This will help you about the color of the wire. So when you will read the machine schematics, you will see these symbols on each line. This symbol shows the wire color, so physically you can find easily the wire on the machines with this code. So what components included in the electrical system? Fuses and relays, continual circuits, ignition circuit, start circuit, charging circuit, light circuit, monitoring circuit, wiper and washer circuit. Now I will tell you how to read this electrical schematics. As already I have told you that I will upload one video relating to the symbols of hydraulic and electrical system. This will help you to read this electrical and hydraulic schematics in easy way. So this is for your understanding. Just I took this one section of drawing from electrical side. This was difficult to tell you each and everything for this complete machine, so just I get this one engine preheating system data so you can understand how we can read the drawings and how you will troubleshoot the machines when there is failure with certain components or certain system. So here you can see the detail of each component. At number one we have two batteries, number two battery relay, number three fusible link, fourth circuit breaker, fuse box. This is 9 preheat indicator lamp. You can see also the C pass controller and 11, 12 engine controller, 7 preheat relay. On 8th you can see the heater. So here you can see the start position, starting switch positions, different position B, B, R, R1, R2, C, accessory. So there are three positions for the starting switch. One is off, second one is on, and third one is start. So if our starting switch is on the off position, then only B point is connected. With point B point, you can see this B point. And this start switch is 5 number 5. Just see inside the circle, this center dot, this is B point. So what is the path of the current? An air heater 8 is installed in the intake manifold of the engine. So air heater is installed in the intake manifold of the engine. When the starter key switch is turned to the on position, let me change this starter position to on. So here you will find in below table point B, point BR, and accessory is also connected. So at this point, when we turn this starter switch to the on position, the current flows from the battery 1. You can see this red line, current flows from here to fusible link 3. Just see this current flows to the fusible link 3. And then this goes to the fuse box 6. And then from here this current comes to the starter switch B position. Now our switch position at on. So at on below table you can see at on position this point B, BR and accessories will connect with each other. So accessories points are also connected. There is no drawing for accessory point as we are discussing this engine preheating system. Here you can see this BR point also connected. From BR this current will go to the diode, through diode to the battery relay, and one line is going to the engine controller, this 1-39 terminal of the controller 12. So what it does when this current comes from BR through diode to the starter relay, battery relay, what it does, this point closes. 2 point closes and current will pass from here, from this line above the diode. You can see one line is coming to the down, and then this line comes to the B point of the preheat relay. So now current is here at B point. This starter switch energizes battery relay. This passes the current to the B terminal of the preheat relay. Now here you can see this preheat relay B and H have no connection because circuit is open. So we were discussing about this engine preheat system. So my recording stopped, and again I connected my voice recorder in the laptop. So I was telling you, this battery relay will energize from starter switch current, and this will pass the current from the battery to the B terminal of this preheat relay. And if you remember, this one line was also going to 139 of engine controller. You can see the detail of this drawings here. Here also you can find the detail of the circuits. So what the controller do, from 139 terminal of engine controller, this passes the current through 116 terminal of engine controller to C point of this preheat relay. And D terminals of this preheat relay, you will find also this D on the opposite side of this relay. D terminal of the preheat relay 7 send back this current to the ground through 101-04 terminal from engine controller. This relay is energized, and now the current was here at B point. Current passes from this B. When this relays become energized, this B and H have connection. Current will pass from this, and this will go to the air heater. Air heater is already grounded. So when the contacts of the preheat relay 7 are closed, the heating coil of the air heating device 8 are heated by current flowing from the battery 1, battery relay 2, preheat relay 7, air heater 8 and ground. So the duration of the heating cycle depends on the temperature of the engine coolant. As already I have told, is the coolant temperature of your engine is about 10 centigrade, there will be no preheating for your engine. If this is lower than 10, then this heating cycle takes place. So if coolant temperature is 5 centigrade, then the heating time for preheating cycle is 10 seconds. And if the coolant temperature is 0 centigrade, then the preheating time is 20 seconds. So once this preheating system switched on, here you can see the preheat indicator lamp. If you see from this battery relay, there is one wire that is leading from this 4 number circuit breaker through fuse box to the preheat indicator. So once this preheating time starts, this preheat relay also is controlling by the engine controller the light in the panel preheating cycle. If this light will display in the panel, so this EPAS and machine controller are connected. These will display the light. Once the preheating cycle times finished, this light will automatically goes off. For further detail, you can see this chart, the detail along with this schematics. You can find the data here also. So identify the faulty circuits. Now you have knowledge of electrical drawings, electrical circuits. This section also for specialized and expert person, expert technicians and engineers. You should have the proper tool for faulty circuit identification and troubleshooting, multimeters, voltmeter and other accessories also. So now we will discuss the hydraulic system of these machines. Hydraulic system consists of following 3 circuits: main circuit, pilot circuit or the turn circuits. Main circuit, mostly this consists of the high pressures. Pilot circuit is just for operating the spools. This works as a signal, as we see in the electrical system. This signal go to the certain function and this operates the main current. This pilot circuit is like signal in the hydraulics, and third one is the auto turn circuits. Here you can see this hydraulic tank. From the hydraulic tank store the hydraulic oil, and from hydraulic tank this hydraulic is sucked by hydraulic pump. Inside the hydraulic pump, this could be the gear pump or variable displacement type pump. Then this hydraulic pump sends this hydraulics to the control valve, hydraulic control valve, and control valve then send this hydraulic to the actuator. Actuators are working devices such as cylinder and motor, etc. Control valve is a direction control actuator. So here you can see the picture of the hydraulic pump. This is not for Doosan, just for your understanding I took this picture. I think this is from Kawasaki. You can see this pilot pump behind this 2 sections. Hydraulic pump, this is the main pump installed with the engine, connect to the engine through a coupling. These are the regulator 1, regulator 2 on the top of the both pumps. Here you can see PI2 and PM2 negative control and flow cutoff controls also installed. EPPR pressure, electronically proportional pressure regulators. EPPR valve air, you can see P1 front, P2 second section of the hydraulic pump, and third one is the pilot pump, which is responsible for pilot pressure. So here you can see the pilot circuit of wheel type excavator. This yellow color is the pilot pump. Pilot pump suck the oil, gets the oil from this hydraulic tank through suction filter. There is suction filter inside the hydraulic tank. This is mesh type, screen type suction filters, and it prevents the metal particle for getting inside the hydraulic intake line or suction lines. From here this you can see there is line filter after this pump. Also the bypass valve is installed with this line filter, and here is the relief valve 40 kgf per centimeter square pressure. So if pressure is above 40 kg, extra pressure will go back to the tank. From here main pump pressure comes to these lines: control valve, safety lock solenoid valve, power boost solenoid valve, travel reverse solenoid valve, travel forward solenoid valve, swing parking brake, boom priority valve, remote control lever, right hand lever, left hand lever. So inside the cabin, as I already told you, we need the pilot pressure. We don't need this high pressure, because from safety point of view, if this line damage or burst, this can cause the serious consequences, including the death of the operator, injury of the operator. So we need pilot pressure inside the cabin when operator this move the relevant function. From there, this pilot pressure directs to the control valve and turn on the relevant function. Now just I have taken one section from the hydraulic circuit just for your understanding. As I already told you about the electrical circuit, we have discussed preheating system. So here we will discuss the bucket dump position circuits. So you can see this arm swing lever. Arm swing levers have 4 position, 1, 2, 3, 4. So at the moment we are discussing this position number 3. When you move the arm swing lever to the right at position number 3, just before going to the circuit detail, I will tell you about the points. This one is for crowd position, bucket crowd position pressure, pilot pressure. Second is this third one is the bucket dump position. Number 2 also for function of the machine. T denotes the tank line. This pressure goes to the tank. 4 is also for another function. So from P, this pilot pressure is coming to this control lever, this joystick. So here the pilot pressure already here at the P line. You can see on the both sides. So when we move this lever to the right side at number 3 position, what it does, this make connection of number 1 and number 3 lines. So we are at the moment discussing this bucket dump position. So when we move this lever to the right on number 3 position, this pressure will go from number 3 here XBK DU, this dump position you see, and here also on right side at control valve you can see this XBK. This pressure will come to this side, and I have highlighted this spool with this red rectangle. This position will move this spool, and this will make a connection of this pressure and return line of main hydraulic pump pressure. So when we move the lever to the right at 3 position, bucket dump position, this pressure comes, pilot pressure comes through 3 number position from the lever XBK to XBK of control control valve, sorry. So here this moves this spool to the right side, and this make a connection of the arrows. Here you can see this red color line, this is the pressure line, and green one is the return line. So here the pressure comes from the XBK to this position, and on XAK, here you can see this XAK on the other side of this control valve. This XAK makes the connection through lever number 1 line XAKCR to the tank. So this is the return. So here you can see this pressure comes through red line to the cylinder. This dump position area, cylinder will move, piston will move inside, bucket position will be in dump. So on the other side, this pressure will go back through this green color line to the tank. Also in the center you can see this is the tank lines, so it will connect the control valve other line to the tank of the machines. Hopefully you got my point, what I have said about the circuit. So this is very easy, just I will upload one video of this hydraulic symbol and electrical symbol. This will help you to read these schematics in easy way. So what are the problem, possible causes and remedies? So here you can see problems detailed in this chart. These all problems are related to the hydraulic system of the machine. For engines, this depends upon the manufacturer of the engine. What engine is installed with your machine? This is Cummins, Caterpillar, John Deere, Komatsu, but this depends upon the engine's manufacturer. So there will be separate service, repairing, troubleshooting guide for the engine. This is totally separate from the engine side. These all problems and causes, remedies are related to the hydraulic system of the machine. So in number one position, you can see this attachment, cylinder, swing and travel motor are all inoperable. Loud noises are heard from main pump assembly. So what could be the cause? Main pump malfunctioning. Low oil level in the hydraulic system. If hydraulic system is low, also the bubble will create. There will be noise in the pump side. Main pump inlet piping or hose damage. So if main pump inlet or suction hose is damaged, then there would be also noise, because less hydraulic is entering on the inlet side of the pump. So this will create a sound inside the pump, and it can damage also the inside parts of the pump. So remedy also there, main pump malfunction. So repair or replace, then check your main pump and rectify the problems, and then repair and replace. If oil system is oil level is low, then refill it. So attachment, cylinder, swing and travel motors are all no usual or loud noise can be heard. Pilot pump malfunctioning, repair, replace. There is also remedy. If your cylinder, swing and travel motors are not operating while no abnormal sound from the pump and your engine is also running, then check the flexible coupling. If coupling damage, then there will be no power transmission from the engine to the pump, so you will find no pressure. Check also the pressure on the pumps. If pilot pump is malfunctioning, your system will not work, because pilot pressure is the signal pressure for control valve, and this opens the main pressure to the relevant function of the machines. Check pilot top solenoids also. In this table you will see sludgy performance of all hydraulic functions, attachment, swings and travels. There is Again, this main pump damage. Sluggish performance, check the main relief valve. If the spring is broken or spool is not moving properly, then also there could be sluggish performance. Check the level of hydraulic oil also. If the strainer is clogged inside, there are strainer inside this mesh type strainer. Check the strainer. If these are clogged, then this will also affect the performance of the hydraulic system. If there is entry inside the pump through pipe or any fitting, tighten the connection also. If oil temperature is abnormally high, so check the oil cooler and air circulation through blocked cooler. Clean it. If there is fan belt, check the cooling fan belt tension. Mostly hydraulic motors are installed, but this machine has cooling fan belt. Check the tension of the cooling fan belt. If this cooling fan belt is loose or this is not operating the fan at desired speed, this will also cause the hydraulic to become high. Check the relief valve. Check this in several cases, but in rare cases this could be the hydraulic oils quality issue. Incorrect hydraulic oil used. One circuit in a hydraulic system is not operating. So spool damage, Darton control valve spool. Check the relevant control valve and circuit which is not operating. Internal seal leak inside the cylinder, cylinder rod damage. Let's suppose this arm cylinder is not moving. So before proceeding to this troubleshooting, keep in mind you will start from the Z, not from the A. If you will start from the A, it will take a lot of time. This is the troubleshooting formula. Start from Z. Always start from the Z. So what is Z? Z is our cylinder, arm cylinder. Check it whether it is enough pressure up to the cylinder hydraulic pressure. If there is no pressure, then you come back in sequence. Check the control valve, pilot valve, relief valve, seals, etc. So this is the most efficient way to troubleshoot the system. Always start from the Z. Travel motor is not operating. Center joint damage check. Parking brake not releasing. If park brake will not release, this will also stop the travel motor from rotating. Travel motor walnut damage, travel pilot piping damage. So there is also pilot pressure for operating this control valve spool of this travel motor. Check also this pilot piping of this travel motor. Travel motor rotates very slowly. So check also travel motor is rotating very slowly. Track tension poorly adjusted. Low oil and idler or roller. Travel brake dragging. Check also this travel brake. Track time out of alignment if I'm twisted. Swing motor is not operating. Swing brake are not releasing. Check the swing brake. Please remember this parking brake functions with this spring applied and hydraulic released. SAHR, spring applied and hydraulic released. So when hydraulic pressure comes, this release the brakes. Either it is parking brake or swing brake. This is the working principle. So if brake is not releasing, your swing motor will not operate. If no issue with brake, check the relief valve, pilot piping damage. So relief valve, park brake and pilot pipe. Three things are responsible for travel motor operation. So check these three. After checking these three, then it could be that your motor is damaged. If these are okay, then motor, check your motor. Swing motors operates unevenly. Swing gear bearing or mounting loose or worn, repair or replace. Lubricate worn away with grease. Swing relief valve may be faulty. So accumulator, here you will find the accumulator. This is like a capacitor in electrical system. So you can see here the photo of the accumulator at upside above the photo of the accumulator, above the picture of the accumulator. Two rectangles, one is with rectangular shapes and second one is plane. So pressure fluid and filled with rectangle triangles. This is the nitrogen. So at first position, no nitrogen inside this accumulator. This is pressure fluid. Some accumulators filled with pressure fluid and some with gas nitrogen. So in second photo you can see this filled with nitrogen, no pressure at point 2 of the accumulator. When this hydraulic pressure comes, number 3 position, you can see this will push the diaphragm of the accumulator at upside. This will store the energy. At number 4 you can see the position of the diaphragm. Number 5th, now this is releasing the stored energy in form of hydraulic stored inside. So number 6, all the hydraulic released. Let me just read the detail. The accumulator is a gas charged device designed to hold a reserve quantity of hydraulic fluid under pressure. Accumulator is used in a hydraulic circuit in much the same way the condenser. Already I told you this, like capacitor, store the energy. So this is mostly used for the brakes in excavators and other relevant functions of the machine. So in case of emergency, you can move the machine or you can operate the brake. Minor variation are lags in pump output that might otherwise cause instability. Irregular operation are made up from supply of pressure oil in the accumulator. So if there is unsteady or irregular flow from the pump, so this make it balance stable. This absorb the pulsation from the hydraulic flow. A hydraulic system pressure overcomes accumulator pre-charge pressure. The flexible diaphragm begins to retract upward, as I already told. If system oil pressure begins to fall off or is momentarily checked or interrupted, the energy stored on the other side of the diaphragm in the form of compressed gas pushes oil back out of the load chamber, maintaining oil pressure of the circuit. So there is pilot and brake pressure accumulators. Charge pressure also given here. You can see 140 to 13 psi for pilot and for brake 427 psi. volume also there, 320 cc and 750 respectively. Here you can see the 160 also, pressure is same, and volume also same for both machines. So swing motor disassembly, just you can read by yourself. Disassembly of the motor. Here you see this. This is just I took one section from this disassembly for your understanding. Remove the brake valve, remove relief valve. Here you can see remove plug, take out spring and plunger from the valve casing, remove swing action valve assembly, remove access socket bolt from the motor and disassemble valve casing. So these numbers are from the manual of the machine, so don't rely on the number. These were just given in the manual for your reference. You just understand how we will disassemble. If any fault in the motor, then obviously you will disassemble, otherwise no need to disassemble. Before troubleshooting, as already we have discussed the problem, causes and remedies. Remove brake valve spring. There are brake valve spring on the top of the motor. Remove these springs. Then disassemble the brake piston from casing by using the special loop for removing the brake piston. Lift it up straight by using the bolt hole in the brake piston. After placing the motor horizontally, take out cylinder plug from the casing. Okay, cylinder plugs have piston, wall plate, wall plug. Remove piston assembly, retainer, spherical bushings, spacer. When taking out the cylinder plug, be careful not to pull out roller. Be careful not to damage the sliding parts of the cylinder plug, spherical bushing and shoe. So take care of these things when removing the cylinder plug. Pull out the friction plates and separate plates from the housing. Remove the switch plate and drive shaft with ball bearing from the casing. Be careful not to damage ball bearing and oil seal contact surface. Disassemble the finish and check each component thoroughly. So disassembling is finished now. Now you have removed all the parts and thoroughly check each and every component for any wear and damage and replace it necessary. Now we will discuss the assembly section of this machine. This swing motor. Place the housing on a work table with valve casing side downward. It is necessary when oil seal was disassembled from the casing, insert oil seal at the casing with the using tool. So if oil seal was removed, so better to replace oil seal whenever you disassemble this motor. Seal and rubber rings must be replaced when you disassemble the components. This is recommended from the manufacturer, because with the passage of time this becomes soft or hard, or becomes loose, or have no more strength. So once you disassemble the parts, after assembly there could be leakage or any failure, so better to replace the seals and O-rings when you are disassembling and again assembling the component. So if Ball bearing was disassembled from the drive shaft, then fitted by heating inside the drive shaft inside the housing with complete ball bearing casing. Assemble also the parallel pins inside the housing. Assemble the swash plate. So insert the roller to cylinder block. Make sure that cylinder block is assembled with all components. If you disassemble the cylinder blocks, then make sure it must be assembled with all the components before installation or assembly. So make sure not to damage the sliding surface of the cylinder blocks. Place spherical bushing to the cylinder block. Assemble the retainer with the piston sub-assemblies units into the cylinder blocks. So insert the cylinder block to drive shaft aligning the splines. So after spline alignment of the cylinder block, so place it in the housing and insert on the shaft. So here place the casing downward and assemble separation plate, this can plate using for this parking brake of the machine. So assemble these plates in sequence and align the notches of the plates. Mount the O-ring also to the casing. Coat little bit O-ring with the grease so it can be assembled easily. And it can also be protected. Assemble the brake piston inside the housing. So this could be the little difficult during assembly of the pistons. Insert two handmade bolts on the brake piston and tape gently with the plastic hammer. In this way you can assemble it easily. So otherwise if you will assemble in uneven way, this could damage the O-ring. Assemble the brake spring into the brake piston. Confirm the spring are fitted to the brake piston completely. A ball bearing was disassembled, so assemble the ball bearing again with the housing. Insert valve casing and tape it lightly. Assemble the valve plate and fit O-ring also. Mount the valve plate with its round part toward the opposite side of the flame. Mount the valve casing and tighten X socket bolt to specification as per specification again. So install the plunger of the control valve and spring. So when you are installing the plunger, just check the movement of the plunger. It should be smooth inside the housing of the control valve. After checking the movement of the plunger, install the plugs on both ends. Install the swing reactionless valve assembly to valve casing. Assemble relief valve with O-ring in the casing. Assemble the brake valve to casing and tighten the hex socket valve to specified torque. Now your assembly is completed, so hopefully you have understood lot about the repairing and troubleshooting of this machines, and today we have completed this Doosan DX140 160 excavator topic. Now you can watch the each sections of the machines in different videos. There are 3 videos with these machines. We have discussed the machine introduction, machine safety in one video. In second video we have discussed general maintenance and specification of the machines. Before proceeding to the third, just I have posted one more video with Doosan DX140 160 components detail. Watch also this video, and the last one is part 3, that is related to the troubleshooting and repairing guide. So hopefully now you are able to work on this machine independently and have lot of knowledge about the machine, and you can proceed your job without any hesitation. Thanks for watching my videos. Please like, watch and subscribe my video. In next video I will bring the hydraulic and electrical symbol details, so you can read the schematics drawings in easy way. These will help you to understand the drawing easily. Thank you. Take care.